Hello guys, so today we are going to look at how we can tackle a wave question. Yes, so a signal is given by the expression v of t is equal to 10 sine into bracket 2 pi t plus pi over 2. We are supposed to find the amplitude, the angular frequency, the linear frequency, the period, and then finally the speed, given that our wavelength or lambda is equal to 5 meters. So without wasting much time, let's dive right into it. Yes, so the first thing that you're supposed to do is you compare the equation given to you with the general wave equation or the sine wave form. So we can see that amplitude is 10 units. And then comparing omega to the general sine wave, you can simply see that omega is going to give us 2 pi. Yes, 2 pi. But don't forget that the unit of angular frequency, which is omega, is rad per second. Yes, so let's go ahead to find for the frequency. Let me clean this off and then get space for us to. So our omega is 2 pi ft. We know that angular frequency is equal to 2 pi ft. So we are going to compare this angular frequency 2 pi ft to the equation that was given to us, which is 2 pi t. So 2 pi t is equal to 2 pi ft. And then now we divide through to make, we are going to make f the subject, which is the frequency. So we are looking for the frequency. So making f the subject, then it means that we have to divide through by 2 pi t, so that simply we can have f to stand alone as an individual entity. So let me wipe this off and then so we get space. All right, so let's go. So we have 2 pi t is equal to 2 pi ft. Then we divide through by 2 pi t. Then we cancel out. So finally we are going to get our frequency to be equal to 1 hertz. Don't forget, the unit for frequency is hertz. Yes, or per second. So here we are going for hertz. All right. So our next question, we're supposed to find the period, right? So the period, we can find the period from the frequency that we just found. Yes, how? Don't worry. Let me wipe this off so we can get space to work on that. Okay, so let's go. So we have t is equal to 1 over f, where f is our frequency. And we know that our frequency is 1 hertz, right? So our period is supposed to be in seconds. So finally we have 1 second as our period. So this implies that our t is equal to 1 second. So from there, I think we're supposed to find the linear frequency. Yes, linear frequency. So let me wipe this off so you can solve that space. Okay, so I think we are set. Now when we see we compare the two equations, you can see that our phi is equal to pi over 2, or our phi corresponds to pi over 2. So we have our phi, or the phase angle, to be pi over 2 rad. Good. And then we can convert this pi over 2 rad to degrees. Yes, so the question they can ask you to find the phase angle in degrees. So if that is the case, let's do that conversion too and see how that conversion also works, right? Okay, so I think we are set to go. So conventionally we know that 2 pi rad is equal to 360 degrees, right? And then we are supposed to find pi over 2 rad. So simply we can say that pi over 2 rad is equal to x, because we don't know for the degrees. Now we are going to look for x, and then our x is going to be the conversion. So we cross multiply the two equations, and then we are going to get, let me wipe this off. So we get, yes, wipe. Okay, so I think we can go. So when we do our cross multiplication, or when we cross multiply, we are going to get 4 pi rad x is equal to 360 degrees multiplied by pi rad. So don't forget we are looking for x. So we are going to divide through by pi rad, and then yes, pi rad. Don't forget our x, yes, because that is actually what we are looking for. So let me put that there. I think we missed it. Yes, so let's put our x there. X. Okay, so now we can finally cancel out. So we can cancel out pi rad, and then we are going to get 4x is equal to 360 degrees, and then we divide through by 4 to get x to stand alone. So finally, when we cancel out, we can see that our x is simply equal to 90 degrees. 90 degrees. So that is for pi over 2 in degrees. Yes, so that is how the conversion works. So you can pause the video and then go through and then see how it was done, just in case you are given a question that you are supposed to convert the pi rad to degrees. Yes, so let's solve our next question by wiping this off. All right, so we are going to find the speed. We know that c is equal to f lambda, where f is frequency, lambda is the wavelength, which was 5 meters, and then the c is the speed of the signal. So frequency was 1 hertz, so 1 hertz multiplied by our lambda, which is 5 meters. Yes, so when we multiply the two, we are simply going to get our speed, which is the c, to be equal to 5 meter per second. Yes, I know you're confused. Yeah, we have hertz there and I'm saying second. Don't worry, we know that t is equal to 1 over f, right? So to find f, we have 1 over t. Very good. So that is the conversion. So we have our speed to be 5 meter per second. Yes, so I think that is it. So let me give you a brief overview of all that we've done so far. So okay, so 1, we found our amplitude, and we saw that our amplitude was equal to 10 units. Because they didn't give you the unit of it, you simply refer to it as unit. Yes, then we have our angular frequency also to be equal to 2 pi rad per second. And then 3, we have our frequency to be 1 hertz. Good. And then don't forget our period. Our period was 1 second. Yes. And then 4, we have our phase angle, which is the phi, to also be equal to pi over 2 rad. Don't forget we did the conversion, so we have 90 degrees for our phase angle. And then finally we have our speed to be equal to 5 meter per second. So this tells us that the signal is running at a speed of 5 meters per second. So every second it covers a space of 5 meters.